So the next talk will be by Thomas Schweiger and Louis Kalckstein from Nagarro. Thomas is very enthusiastic about AI and machine learning, and I liked this sentence in the description. He's passionate about making the daily lives of test teams easier with the help of artificial intelligence. So I guess everyone who ever worked in a test team will appreciate that very much. And Louis is also a data scientist at Nagarro, and we're very keen to hear your talk.
Thank you. So first question, how can you ensure a good quality in a big software project? Of course, with a lot of tests. So imagine you're a software tester coming to work and having a lot of tests failed. If you have a good test coverage, more than one test fails if something is wrong. So you have a lot of failed tests. How can you think, how can you find out what the root cause of the problem is? And therefore, you need to check a lot of logs, a lot of log lines within the different test executions. And that's a lot of work, which we are trying to tackle with machine learning.
Okay. As already mentioned, my name is Thomas Schweiger. I'm a data scientist at Nagarro. And this problem of analyzing huge test case portfolios bugged me a lot for quite some time, as I worked for quite some time as a software testing engineer. And I'm going to click it. Oh, great. So, and for that, we started a research project at Nagarro. And I also did my master thesis on the area of test result analysis. And this is a slide I show in every presentation I do on that topic, because this is something I really like to stress out. The goal of our research project isn't to get rid of software testers, because the goal of our research project is to free them from the boring and repetitive stuff. And if you do software testing, there is really a lot of boring and repetitive tasks. So this is just to let you know what is the goal. The goal is bring free software testers to do the fun part of the job, like creating test cases, like writing test automation scripts, and not tasks like analyzing test cases. When we talk about testing automation, or the only thing that is automated at testing automation normally is running automated test scripts. Everything else in the testing life cycle, like reporting, defect analysis, like test case design, like test case selection, are normally manual tasks done by testing engineers every day. And so our research project, the main idea behind the research project was thinking about how can we automate more? How can we automate test case design? How can we automate test result analysis? And how can we automate test case selection, test data generation? So this was the main reason we started all of this. And today we will focus on the reporting and test case analysis part. So we really want to focus on how can we support testing engineers when they need to analyze failed test cases. And for that, I have my colleague here, Louis, who is quite a rising star. And he will give you a short overview of what we are using for that.
Yeah, thank you. I'm Louis. I'm from HTL Spengergasse, same as Somya, who talked about quantum machine learning. And we have some use cases of AI in our process. First of all, GPT. Sadly, there is no bar here. But with GPT, we're also trying to automate something in that region. The clip part is about UI elements. How can we use computer vision models to automatically identify UI model elements, for example. But what we're focusing on today is the Squid AI we're working on at the moment to detect root cause and further support the tester.
Here you have an architectural overview of our root cause analysis system, which we call SquidAI. And I really want to walk you through this architectural diagram because it shows two parts. First of all, what information do we need to analyze test cases? And the other part is we are not doing this research project only for research purposes. We also want to bring it into production and to our customers. And for that, when you take a research project out of research area into the real life, you face some new challenges. And I would like to point out some of those challenges and how we had to address them. So first of all, you see our inputs. Which is this? We use different encodings as an input. When a testing engineer is analyzing test scripts or test results, there are many different inputs they're using. So something like the error message from the testing framework, log files produced by the test script, log files produced by the system under test, screenshots produced by the testing framework when the test case failed. And to get all of this information, we use BERT encodings. BERT is a transformer model for language processing. We use image encodings, so we create image hashes out of the screenshots to compare, are those different screenshots than the last time, are those the same screenshots? And we use additional features like software version, like browser that was used for running that test, and so on. So whatever suits the customer's need and whatever helps the testing engineer to get behind the root cause of this error. Then testing engineers have to do some manual labeling. So they analyze test cases and give us the idea, okay, what was the root cause? Was it because test data wasn't good? Was it because the test script had a failure? Was it really a bug in the system under test? Was it some infrastructure-related troubles? Those information, so our input encodings and those labels are then trained in a classification model, a neural network, that will predict why test cases have failed in the future. However, when you take all of this, because in theory this works quite fine, but when you take all of this and bring it to production and to real-world use, you face quite some issues. First of all, how do you version your models? You train models, you retrain them. There are new test cases, new failure reasons. Testers provide new labels, so you need to retrain the model. For that, you need somehow store your models that you train, and you need somehow have a kind of a registry where you set which model is used now. And when you have it in a bigger organization, there is not just one testing team, there are different testing teams working with different technologies. So there is not a one-fits-all model. So maybe each testing project there has a different model. For that, we also needed this model registry to store the information, which testing project needs access to which model is trained on which data. Additionally to that, doing all this encoding, doing this natural language processing, doing this image encoding takes quite some time. And when we talk about a lot of failed test cases, we talk about thousands of them. So for that, we needed to implement a caching mechanism to store this encoded data, because otherwise we would have to do it on the fly each time, and it takes a lot of time. And when we have all this together, and we have our trained model, the best case is that this model is quite confident and cannot tell us why our test cases have failed. But what happens when the model is not confident? We thought about it, and we didn't want to stop there. It was like, okay, we have this model, but when half of the time the model isn't confident enough, how can we support software testers more? How can we support them even when the model isn't confident enough? And Luis, tell us.
Exactly. So how can we still support the software tester? As I told you, software test execution consists of many, many log lines. So what we're predicting is which log line is interesting. We're predicting which log line contains the most valuable, the most critical information in order to find the root cause of our problem. And therefore, we can also say which test execution contains how much interesting log lines, because we're saying, let's say 20% of the log lines contained in one test execution are interesting. We can also, then we know which test execution contains most of the interesting information, and therefore the tester knows where to look at first. How do we get the data? It's first manually classified. So in the first runs of the project, the tester needs to go through the log lines as before and select the interesting ones. We're currently in research and developing, so we also face some quite hard challenges. First of all, the training quantity. We want to support the tester as soon as possible, so to have not much training data should be fine. As well, what if it's interesting to have a certain combination of log lines? If that's interesting, we cannot detect it yet with usual text classification. And yeah, if you have ideas, don't hesitate to approach us and tell us about your ideas. Yeah, but what if all the test cases succeeded, or at least they seem to succeeded, but something is wrong? We want to still detect it, or at least we are trying, with anomaly detection. Anomaly detection on the base of log lines. So if there is something unusual, for example, yeah, the login happened before he even tried to log in. I mean, it could be the case, and it should be detected even when the test case login check was true. And as well, the execution times. What if some test took even longer? And what are the challenges here? When should we retrain the model? New tests are executed when something in the software changed. And when something in the software changed, there are also new logs. And new logs are not known to our model, but it should not be directly be classified as anomaly. So how and when do you retrain the model so that it does not detect all the new information as anomaly? And as well, how can we detect if certain combinations are interesting, if that's the case? Yeah, so here you can see our decision tree when we try to help the tester, in which case, so if the test results passed, then we still perform anomaly detection, or we plan to. And yeah, as you can see here, our root cause analysis with the log importance prediction if the certainty and the confidence is low. Yeah.
So to sum everything up, what are we trying to do with our root cause analysis mechanism? First of all, we want to find root causes based on information we already have from software testers. If our model isn't confident enough, we try to support testing engineers by highlighting that information that they need for analyzing the test cases. So find those log lines that provide the most valued information for them. And in the end, what we are trying to do next is how can we catch failures that are undetected because test cases are passed, but still something was wrong. So this is the next thing we want to do, because we strongly believe that you can save quite a lot of time by catching those failures early and not in production. Okay, so that's it. Thanks a lot. If you have any questions, please feel free, and we gladly answer them. Thank you.
So, thank you very much for this interesting talk. So, I think we have time for one short question. Yes?
What models do you use for this classification task?
For the classification task, we use usually two different models. We have a simple random forest, because the random forest works quite well in the beginning phase when we don't have much data. So when at the beginning, when testers are starting to label the data. And after some time, we switch to a neural network when we have enough labels.
How do you perform the switch between the...
Manually. So we in our registry, we can set which model to use. And then we train the neural network on the data we have and set in the registry to use this model from now on.
Okay, thank you.
Yeah, maybe one last quick question.
Thank you for the presentation. Yeah, so I had one quick question. Suppose I have a software company where I don't do it like in a good way, like hashing any passwords or anything, right? How do you deal with those information that you get on your system? So let's say you get a lot of problems with having wrong passwords, let's say for a login as a Sage or something like that. How do you handle dealing with that kind of information?
You mean dealing in the sense of how do we
like hide or protect those kind of information to not suggest to someone else some information that you shouldn't have done?
Okay, I see. So what we usually we are talking in test automation when you do it quite the way you're supposed to. Mm-hmm. You work with artificial data, so you never would use something like production data, mm-hmm. or if you have to use something like production data, mm-hmm. you need to do an anonymization steps for that. Mm-hmm. So we don't face quite a lot of security issues here in the normally. Mm-hmm. However, those models are not some public models or some centralized models where we train the data of different customers on one model. Mm-hmm. So each model trained is in the hand of our customer, in their infrastructure, and it doesn't leave their infrastructure.
Okay, so basically if I'm using a model, I'm not like using any knowledge from different companies. I'm
yes.
basically using my company's
mm-hmm.
knowledge.
Yes.
Okay, thank you.
You're welcome.
Yeah,
Okay, then thank you again, Thomas and Luis.
Thank you very much.
So also for you are present.
Thank you.